Hi, today I will be demonstrating how to configure the intelliTeso plug-and-play HVAC controller and describing its various features and functionality. Using this built-in web interface of the intelliTeso HVAC controller, a user can easily configure their HVAC system using simple drop-down list of options. Before we can start configuring the HVAC system, we need to ensure that the HVAC system is turned off. If this is not the case, then an error window will pop up preventing the user to proceed towards configuring the system. Let's go ahead and click on the configuration button to begin. Now, on the basic configuration window, we have a list of options to choose from. The user can define the number of refrigeration circuits. The user can define the number of compressors per refrigeration circuit, the number of condenser fans, number of heater banks, to have pulse width modulation enabled or disabled on the heaters, to choose the temperature control algorithm between hysteresis and fuzzy logic, define supply fan control to be either digital or analog, define fresh air damper control to be either digital or analog, define pressure sensor configuration to be either simple, dual, or analog. If the user has selected analog as the pressure sensor configuration, the next set of settings that needs to be defined are the pressure sensor constraints. The maximum and minimum value for the discharge pressure and the suction pressure are defined here. Next, the user defines the thermistor probe constraints, which includes the maximum value, the minimum value, the beta value, and the resistance at 25 degrees centigrade. Now we click Next to go to the Set Points tab. The first option here is to choose how the fresh air set point is calculated. The user can choose between three options: the actual value read from the fresh air sensor, the timed average value over a period, the cycle average value calculated at each software run cycle. Next, the higher and lower limit of the set points is defined, which is then used in a calculation to optimize the HVAC operation. Now we click Next to go to the temperature offset control. In this section, the user defines the temperature offset with respect to the set point defined in the previous tab. Each cooling stage in the list provides cooling capacity with one compressor. So at cooling stage 4, 4 compressors would be running. The heating stages operate different as compared to the cooling stages, where heat stage 1 provides heating by running one heater at PID control duty cycle. Heat stage 2 provides heating by running one heater continuously. Heat stage 3 provides heating by running one heater continuously and running the second heater at PID control duty cycle. Heat stage 4 provides heating by running both heaters continuously. Values can be defined by either typing them in or using sliders. Now that we have defined the temperature offsets, we can go ahead and click on Save. The system then validates the configuration and gives a success message indicating that the HVAC system is now configured to the user-defined settings. Now let's click on the PNID tab to see the HVAC system configuration diagram. Now, towards the top, we have a status section which provides a quick status for different parameters of the HVAC, like return air temperature, set point, compressor status. We can also see run hours for the HVAC controller, the supply fan, compressor fan, and heaters. Now, this PNID diagram here gets generated automatically from the settings we defined earlier in the configuration tab. We can see that we have 2 refrigeration circuits, 2 condenser fans, 2 compressors per refrigeration circuit, and 2 heater banks. Now let's go ahead and turn on the HVAC system to observe its operation in real time. We can see that the operation mode of the HVAC has now switched to ventilation mode, as the return air temperature reading is close to the set point value. The supply fan is currently running. Now, I will increase the return air temperature value to 23.5, which was the offset defined in the configuration tab to run one compressor. We can now see that condenser fan 1 has started running, solenoid valve 1 is in open state, and low pressure 1 starts stabilizing, which then starts compressor 1A. The operation mode is now at cooling stage 1. The system prioritizes which compressor or heater turns on first by observing their total operating time and operates the one with the least run hours first. Next, I will increase the return air temperature value to 28 degrees so we can observe the HVAC system running in full capacity. We can see that condenser fan 2 has also started. Solenoid valve 2 is in open state and low pressure 2 has started stabilizing. The system then gradually turns on all 4 compressors in the priority of their run hours. The operation mode is now at cooling stage number 3, and now it has switched to cooling stage number 4. That means all 4 compressors are running. Now, let's have a look at some of the other features. The I/O monitor page shows the current state for all digital and analog inputs and outputs on the HVAC controller unit. Green indication represents a digital signal being active, and analog values are displayed as text. The alarm page shows any active alarms present in the system in real time. A red indication represents an active alarm condition. The user also has the ability to reset alarms. The test page provides the maintainer with the ability to force operation modes for testing purpose. To demonstrate this, I will click on Test Ventilation and now look at the PNID tab to observe how the system reacts. We can see that gradually the system is shutting down all compressors in a sequence to prevent damage to the HVAC unit. For this demonstration, the compressor shutoff and startup time has been adjusted to a shorter period. Slowly you'll see compressor 2A is stopped, compressor 1B is stopped, compressor 1A is stopped, and compressor 2B will soon be stopped as well. And now we are in a shutdown position. Only test ventilation is working. I will now go back to the test page and click on Reset so the HVAC unit can carry out its operation normally. We can see that the system is gradually ramping up and will reach cooling stage 4 as it did previously. The advanced configuration page provides more control to a user to manually adjust various parameters such as delay transitioning to cooling after heating if this is required. The user can also revert settings by pressing the default button. The force output page provides the user with the ability to force outputs to test various components of the HVAC system. Towards the bottom of the page, the user will need to enable force outputs options to be able to use this feature, followed by selecting true values or typing values for the respective component to be tested. The simulation page provides the user with the ability to simulate inputs for testing purpose. Towards the bottom of the page, the user will need to enable simulation option to enable this feature, followed by selecting true values or typing values for the respective components to be tested. For ease, status of outputs such as compressor and fresh air damper are available on this page so the user can observe how the system reacts as they change various inputs such as return air temperature value of the HVAC system. The variables page shows a table view of different HVAC parameters. The user can change values here by clicking on the variable and typing in custom values. This is similar to the Advanced Configuration tab that we discussed earlier and can be used if more control is required. The Software tab provides information on the software currently running on the HVAC controller. The Logs page gives the user the ability to download data logs and event logs stored locally on the HVAC controller in CSV format for use with applications such as Microsoft Excel. It also provides a summary of fault occurrences with timestamp data for the user to identify any possible faults with their HVAC system. The Device page displays the HVAC controller statistics such as temperature, run hours, operating system. The user can also update the real-time clock settings. They can also update network settings by changing the IP address of the Ethernet port of the HVAC controller. The File Upload section allows the user to drag and drop software update files or web page customization files to change color and logo settings of the HVAC controller's web interface. In addition to these features described in this demonstration, the user can also view the serial number information, MAC address, and IP address information of the HVAC controller. And this concludes the intelliTeso plug-and-play HVAC controller demonstration. Thank you for watching.